Hello everybody again, my name is Colin. The final project topic I chose was poker. Here's an outline of the presentation. I'm going to go through most of it fairly quickly. There's a lot to present and I want to get to the results. So poker has a lot of hidden knowledge coming both from the player's hidden cards, but also the motivation behind player actions. Are they bluffing? Are they being deceitful? Are they being honest and they can't hide it? And the two pieces of information we collected is poker statistics and poker strategies. Statistics is just how likely I have the winning hand at the end, or that I will have the winning hand at the end. And then strategies is how I play against a specific person or a specific playing style. It's strategies that most people are interested in collecting. So the data set that we were able to obtain has three different data tables. There's a table, which talks about the seat position, and there's a hand ID unique field in each one of these tables. And that's how you're going to tie or associate entries in each data table together. The second data table is the hand data table. It has a lot of the public information. So the dealer community cards, the pot size, the number of players at each turn. Some of these columns have to be split up, so the slash that we see is not actual arithmetic expression, it's just a delimiter. So each one of those columns is broken up to two separate columns. And then the card column was also split up into two columns, one being the rank of the card and one being the suit of the card. So if it was an ace of heart, one column would be the ace, one column would be the heart. And that was so we can ignore some of the information during model fitting and prediction. Specifically the suit of the card. It's very unlikely that that's going to come into play, unless it's a flush or a straight flush. But sometimes we can ignore that. The last data table is the player data table. Now this talks about the player's actions, which actually are also public information. But then the player's cards. These are the hidden fields or the hidden columns that we're looking at modeling and predicting. Again, those card columns are split up to two different columns, one being rank and one being suit. So the two algorithms I ran for this project is the naive Bayes classifier. We ran that just as a baseline to compare SVM against to see how it was doing. So the overall approach is to build a single data table to feed into the algorithms. So what we're going to do is start with that hand data table, and then we're going to look into the table data table and get a list of the players. From there, we're going to do lookups into the player data tables and append that onto the hand data table. So now one entry in the hand data table has all of the information that we need to process. That table will be split up to X columns and Y columns. X columns are going to be all the public information, the dealer cards, the player actions, the player chip counts, and all the Y columns are going to be the hidden information. Generally or exactly those hidden cards that the player is holding. And then one obstacle that we had to deal with is multi-class prediction or classification. This is not binary classification. The output classes are the cards or the card rank and card suit. So what we did is we built a binary classifier for each one of the output classes. And then during prediction, we run those classifiers, all of them, on the input example. And then we select the class that gives the highest probability. So here are some results. The first result is just comparing naive Bayes versus SVM. We can see here that SVM generally is the winner. And then here's some of the more interesting data. So this is the resulting weight vectors from SVM. And of course, the higher the weight, the more important that feature is to the prediction. So we can see here an example of a tight player. For him, the community cards are very important, and his actions also show that he checks most of the time until he gets to the turn, which is a later street. So this indicates that he's waiting to make his hand before he puts money into the pot. And on the opposite side of the spectrum, this is more an aggressive player. You can see the distribution over the community cards is almost equal. He doesn't really care too much about what comes out. But the actions are almost the opposite. He's raising on almost every opportunity. So generally, aggressive players are not banking that they have a hand. They're just banking on that you don't make your hand. Some of the performance seen in this project, since we are using the all versus one, there is n squared classifiers, n being the number of output classes. And that's per column that we're trying to predict. And since we have 4 columns, there's 2 different cards, and each card has a suit and a rank. There's a lot of classifiers that needed to be built and run during prediction. And then the resulting SVM weight vectors really need to be looked at by a domain expert. Some of them show very obvious information or very obvious playing styles, and it's not really interesting to report that. So all the SVM weight vectors really need to be looked at by a domain expert to see if they're interesting or not. The main lesson of this project was to do more background research before the proposal time, and that might be obvious, but I did have a good amount of poker background, but not specifically data mining in poker. Having multiple classes, having to scrub the data set, having missing information was all details that I haven't come across until this project. And then most of the insights are coming from those SVM weights. Again, that is something I haven't done previous, though I had an understanding of how the weight vector shows you the relevant fields and features. I've actually never done that in practice. So overall project evaluation, like I said, the pre-processing took a lot more time than I was expecting. But the initial algorithm and using SVM with a linear kernel was very positive and showed really good results. Much more can be done either by creating a different kernel or changing columns, adding more columns, deleting more columns, maybe not separating columns like we did. But overall, the project was a success. Any questions?